good. Okay, so 4.3, we're eventually going to get into our third form of the equation of parabola. I need maybe 10 minutes before we get into that. But we need to talk about how to find the x-intercepts of a parabola. We know how to find the y-intercept, really easy if you're in standard form. We know how to find the vertex, really easy from vertex form if you're in standard form, though we could do negative b over 2a. But we haven't talked about the x-intercepts yet. If I have some random parabola that looks like this, how many x-intercepts are there? 2. Will there always be 2 x-intercepts? Okay, so what might it look like if there weren't? Could we ever have no x-intercepts? What would that look like? First one completely above the x-axis, or it could be an upside-down parabola completely below the x-axis. Is it possible to ever have one x-intercept? Raise your hand if you think you can tell me what that might look like. Alex? Yeah, if it just touches the x-axis. And we'll deal with that stuff a little bit later. But we need to figure out how to actually calculate these things. So in the one the random little parabola I drew over there, there are 2 x-intercepts. Now, for the x-intercepts, this kind of goes back to the summer work with the lines. Something is 0. Is the x-coordinate 0 or is the y-coordinate 0? Anna? Y. Both of these are things in the form some number, comma 0. It's like saying it's crossing the x-axis at a height of 0. Well, of course it's at a height of 0 if that's where it's just crossing the x-axis. This gives me a formula that I can use to find the x-intercepts. What we're going to do, so we're going to take a look at this parabola over here. What we're going to do is we're going to set y equal to 0, and we're going to solve that equation that we get. Set y equal to 0, and solve the equation. So I'm going to plug in 0 for y. It's a lot easier to plug it in for x, but here we've got to plug it in for y because that's how we find x-intercepts. You know how to solve that equation, right? I feel like we just had a test. Actually, you know a bunch of ways to solve that equation. There's factoring, there's completing the square, there's quadratic formula. That's not a bad one to factor. Go factor that thing. Okay. That look like you're factoring? Possibly. Multiply to negative 40, add to 3, x plus 8x minus 5, I hope. So x is 8 and negative 5? Not at all. What is 8? What is x? Negative 8, positive 5. You set the 2 parts equal to 0. This is like one of the few places where I don't have to see that algebra. X is negative 8 and 5. However, there's one more little thing that I need. These are points on your parabola, so we need to give the answers as coordinates. Give the answers as coordinates. Which means one of my x-intercepts is negative 8 comma, ooh. How do we find the y value? It's just what? Not 1. It's just 0 because that's how we found it in the first place. We found it by plugging in 0 for y. So it's going to be negative 8 comma 0. And what's the other one? 5 comma 0. Y coordinate's always going to be 0 because that's how we're finding these things. We're plugging in 0 for y. Questions so far? Letter A. We want to find the coordinates of the x-intercepts of that parabola, so I'm going to go and plug in 0 for y. I want to factor this thing. What can I do on the right to help me factor this thing? Leah? divide, or we could factor out negative 3. It is an equation, so I guess we could divide here, but I'm going to go and factor it out. Leah, if you do that, what's left?
X squared plus 5x plus 6.
Really close. What was that? Minus 6, because negative 3 times that negative 6 will give you 18. Well, I feel like what's left is something you can handle. Go factor that thing. Maybe we'll do the solving part together because there's one little piece we have to discuss. Maybe. Multiply to negative 6, add 5. Selma, do you have the factoring? That'll do it. Then, we need to set all the parts equal to 0. So we're going to get x equals 1 from this factor. We're going to get x equals negative 6 from this factor. What about the negative 3 out front? Okay, so you see where I got 1 and negative 6 from? So I'm really saying x minus 1 equals 0. I'm saying x plus 6 equals 0. I'm solving those. That negative 3, I could make another equation too. I could say negative 3 equals 0. What does that give you? Negative 3 equals 0. What's the answer to that equation? Undefined, no solution. You can't solve negative 3 equals 0. That negative 3 out front doesn't give you any solutions. They just come from the other pieces. Of course, I should write these as coordinates, though, so 1 comma 0 and negative 6 comma 0. So sometimes we may have to factor out a GCF, and then we can keep factoring. Letter B. First step is very easy. We're going to plug in 0 where the y is. 0 equals x squared minus 6x minus 99. We're going to factor that, maybe. Yes? Factor? I'll give you a hint. It can't be factored. Could we still have x-intercepts, though, even if we can't factor it? Yeah, I think it's possible. How can we solve this if we can't factor? We could complete the square, which actually wouldn't be awful in this one, but I think there's a slightly easier way. What's another method? Let's try the quadratic formula. That's always an option. It takes longer than factoring, I think, but if we can't factor the thing, I think quadratic formula is a good option. Solve with the quadratic formula. Well, go do that. And you might want your calculators. And you know the usual. Once you get your number under the root, you've got to simplify that and break things down. So do some of that. Could you get 432 under your root? Start breaking things down. Look for some perfect squares inside there. Tim, what did you do with that 432? Yeah, if you couldn't find 144, wouldn't expect that, you can use 36, you could use 4, you could use 9, but 144 will be the biggest perfect square inside there. So we can say 6 plus or minus 12 root 3 over 2. And Savage, what does that become? What do we do next?
3 plus or minus 6 root 3.
Yep, we're going to divide everything by 2. And if you're not just seeing that, you can certainly separate your fraction like we did in the last chapter. We're going to get 3 plus or minus 6 root 3. I still need coordinates, though. One of my x coordinates is 3 plus 6 root 3. What's the y? 0. It's always 0 when we're finding x-intercepts. The other one is 3 minus 6 root 3. And if you don't really like the fact that these aren't nice whole numbers, these are still valid numbers. If you type this into the calculator, you're going to get some decimal. We could certainly cross the x-axis at some decimal place. But I do want the exact answers over. Questions so far? Solve these things by factoring when you can, but if you can't, we'll have to go and use quadratic form. We need to talk about the third way to solve, third form of a quadratic function. We had vertex form, we had standard form, and now we have what's called factored form. Is that what I called it in here? Yeah, factored form. On the next page. Factored form for a quadratic function looks like the following. Looks like y equals a, some number out front, times x minus p times x minus q. Factored form because it looks like something that was factored. If we wanted to find the x-intercepts and we set these parts equal to 0, what would you get for x if you set x minus p equal to 0? Don't overthink. It's going to be a letter. P. And when you set the other one equal to 0, you're going to get q. P, comma 0 and q, comma 0 are the x-intercepts. Whatever makes each factor equal 0, well, that's the x-coordinate of the x-intercept, which is going to make factored form very useful for us to find x-intercepts quickly. So let's take a look at that example in the box. I want to graph that parabola y equals negative 2 times x plus 3 times x minus 1. I don't want to convert this to another form. I want to see how I can use this new factored form to be able to graph it quickly. First thing I'm going to do is I'm going to find the x-intercepts, and I'm going to plot them. Find the x-intercepts and plot them. Which really just means setting the two factors equal to 0. That first factor gives you x equals what? Negative 3. Second factor gives you x equals, this is not a hard question, just say it, everybody. 1. Oh, good. My x-intercepts are negative 3, 0, and 1, 0. So I'm going to go and I'm going to plot those 2 points. Negative 3, 0, 1, 0. I got to get the vertex, though. How can I quickly find, like, the vertex? I can. That's not going to be quick, though. Let's look at the graph. I've got an x-intercept here. I've got an x-intercept here. Where's the vertex going to, like, have to be located, Abby? like exactly halfway in between those x-intercepts. So the x-coordinate of the vertex is exactly halfway between the x-intercepts. Let me write that down for step 2. The x-coordinates of the vertex is halfway between the x-intercepts. I think in this case, it's not too difficult to look at the graph and know the x-coordinate. What x-coordinate is exactly halfway between -3 and 1? -1. Oh, this uses something from last year. What was it called when you found, like, the thing in the middle? But distance formula, no. We're really finding, like, the midpoint of those two things. Well, at least for the x part. If it wasn't as easy as just counting things here, we could do a formula. Add the 2, divide. The average of the two x's we already have. X-coordinate of the vertex is -1. Y-coordinate, though, isn't 0, so it's not really just a midpoint. How do we find a y-coordinate, though? How do we always find a y-coordinate? Jack? That's exactly what we're going to do. Step number 3, we're going to find the y-coordinate of the vertex by plugging in. Find the y-coordinates of the vertex by plugging in. I'm going to go back to that original. I'm going to do -2 times, in parentheses, -1 plus 3 times -1 minus 1. I will definitely not be foiling this. I'm just going to use order of operations to figure it out. This is -2 times 2 times -2. I think that's +8. My vertex is -1, 8. So this is really our third way of finding a vertex. If we have the x-intercept, it's halfway in between, and then you plug in. I should plot that vertex. -1, 8. There's a very easy fourth step. Do you kind of see the parabola being formed? Step 4, connect the dots. All I'm going to need here, honestly, are 3 points. The two x-intercepts and the vertex. That's our parabola. That's how we're going to plot these from factored form. We're going to quickly find the x-intercepts. That shouldn't be super hard. Then vertex is halfway in between, and we'll plug it in to get the y. Take a look at the next page. Letter A. Hopefully we can get through both of these, and then we'll be done for today. X-intercepts. X equals what? 3 and -2. If I don't say give the coordinates, I don't need you to actually write them out, so I'm just going to go straight to plotting these things. The vertex. This is a little bit unpleasant. A little bit. Is it like a nice, good number in between? No. I'm not entirely sure what's going to happen, so why don't I actually go and use that formula of do the average of the x's, or like the midpoint of the x's. Vertex is going to be x equals, well, 3 plus -2 divided by 2. I think your x-coordinate's a half. If you look at x equals 1/2, does that seem kind of reasonable that, yeah, it's halfway in between? Okay, this is the little bit unpleasant part. You guys can come in and just leave stuff in the box. Come on in. Absolutely. Thank you very much. It's in the box. Right there. Okay, so we need to be doing the problem 1/2 minus 3 and 1/2 plus 2. Do you see how I got the 1/2 and how I'm plugging in? Yes, or nod your head if you're with me. Okay. Thank you, and pencil. Thank you. So 1/2 minus 3, I don't know, but I'd rather do 1/2 minus 6 halves. And 1/2 plus 2, I'd rather do 1/2 plus 4 halves. I think that's going to give me -5 halves times 5 halves. negative 25/4. I'd like you to write the fraction, but you might want to think about it as a decimal. You might want to type it in the calculator, get a decimal for this. Let's see, a half comma, a little bit under negative 6, so like about there. There will sometimes be fractions like those. I won't make them horrible fractions, but that's how you're going to have to work with those fractions. You're going to try letter B on your own. By the way, in letter B, what's the a value? And we never really talked about the a value for these factored form ones. What is the a value, though, in B? 3. You know why we didn't talk about the a value before? What was that? What do you think the a value does? Narrower, wider, or up or down. The exact same thing as it did before is what's going to happen over here. This is nothing new. That's why we didn't bother talking about the a value. It doesn't really affect our calculations, but it will kind of affect the shape of the graph. You try letter B right now on your own. And while you're doing this, I'm going to pass out the cumulative review due next week. I'm also going to pass out the optional review for the quiz. I think that the regular homework due Tuesday is pretty short, so you can take that time and do that optional review. And nothing that we're doing right now is on that quiz on Monday. Not Monday, Tuesday. And Tuesday I'll also have term grades for you. I just haven't figured out all the last details, haven't talked to Lois quiz yet. That's the plan for the weekend. I feel like in letter B, things are going to be nice, like no fractions. Again, with the optional review, my work for all the problems is posted on the website. Answers are at the end, but my work for everything is on the website, so definitely use that as you're going to study for this quiz. So x-intercepts. Did you get -2 and -6 for the x-coordinates of the x-intercepts? If I actually asked you for the whole coordinates, you'd say -2, 0, -6, 0. Vertex, what's the x-coordinate of the vertex? -4. Either calculate it or just count it for halfway in between. 3 times -4 plus 2 times -4 plus 6. 3 times -2 times +2. -6 times 2, -12, I believe. -4, -12. That's over here. Do you see this is kind of looking narrower than a regular parabola? Definitely opening up because the a value is 3. Maybe, possibly. Please put up the chairs. Stop this.